Hi, my name is John, and welcome to another edition of A Likely Story. Today I want to talk to you about something called the Drake equation. It was developed by a mathematician named Frank Drake. He actually died last year, he lived to be 92 years old. This was developed back in the early 60s, late 50s perhaps, early 60s, and it tries to predict the number of civilizations in the Milky Way Galaxy with which communication might be possible. Now, before you kind of react to that, let me explain that actually the concepts are pretty basic. The assumptions, well, there's a wide range of opinions on the assumptions that could be made. But anyway, so what is the Drake equation? All right. It is found by multiplying quite a few things together, okay? N is the number of civilizations in the Milky Way Galaxy, excuse me, with which communication might be possible. So that's what we're trying to predict. We're going to multiply it by these 7 numbers, okay? We have R sub S, which is the average rate of star formation in our galaxy. F sub P is the fraction of those stars that have planets. N sub E is the average number of planets that can potentially support life per star that has planets. And then we have some F's here. F sub L is the fraction of planets that could support life that actually develop life at some point. F sub I is the fraction of planets with life that actually go on to develop intelligent life. F sub C is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And then finally, we have an L, which is the length of time for which those civilizations would release detectable signals into space. Okay, you can find this on the Wikipedia page under Drake equation. The equation looks kind of intimidating, but I'm going to break it down to show that the concept is actually pretty basic, okay? Before going further, I want to discuss 2 common concepts in probability that is related to this, okay? What are those concepts? Number 1 is to find the probability of 2 or more things happening. You multiply the probabilities. Number 2 is to find the number of ways of 2 or more things can happen. You multiply by each of the number of ways, okay? I'm going to give an example of each. So to flip a coin and to roll a die, let's just say we want to find the probability of flipping a tail and rolling a 4. Well, the probability of flipping a tail is 1 out of 2. Probability of rolling a 4 is 1 out of 6. We multiply them together, we get 1/12, okay? That's the first kind, where you're multiplying probabilities. The second is to find the number of ways, and I just made this up, of course, both of these, find the number of ways that we might want to plan a 3-day weekend, right? And of course, there's many different ways that we can do this. When we talk about number of ways, very often we word that as actions, right? So for example, if we say there's 4 ways to do something, we might say 4 actions to do something. And of course, if you're on vacation or if you're ordering food or whatever, each of those ways, i.e. actions, you can kind of slice it any way you want, right? For example, if you're on vacation and you want to just do one of 2 things on a particular day, there's only 2 actions that are possible for you because you've decided one of just 2 possibilities. But if you're there with your spouse and you say, well, we can do one of 10 things, well, then there's 10 actions, okay? So let's just say you're on a 3-day weekend, and on Friday you say, well, we're either going to golf or go to the beach. On Saturday, we're either going to hike or go to the museum, or we're going to go to a national park. Sunday, we're going to go to a beach, or we're going to water ski. Well, 2 ways to do this, 3 ways to do this, 2 ways to do this, or we could call them actions. Number of ways to do all 3 things, 2 times 3 times 2 is 12. Very simple, common concepts in probability. First one, we're dealing with probabilities. Notice probabilities are always between 0 and 1. Second is number of ways. Okay, number of ways like 2, 3, etc. So 2 different concepts, but both the similarity is that you're multiplying. Okay, how does this lend itself to the Drake equation? Well, the Drake equation is actually multiplying a bunch of probabilities together, and then eventually it multiplies just a number of ways. So it's kind of combining the concepts, which we can do. In fact, getting back to the coin flip example, let's just say that you did that 3 different times. So you're going to flip a coin and roll a die 3 times, and you wanted to know the expected number of times you got flipping a tail and rolling a 4. You would multiply that 1/6 by 1/2 by 3, because 3 is the number of times, and it's very akin to the number of ways. So you're kind of combining both concepts, but in any case, you're multiplying. Okay, so let's look back at this and just kind of try to conceptualize what's going on, right? So we have civilizations in the Milky Way Galaxy, right? They have a certain number of stars, right? These stars, of these, some have planets. Of the planets, some potentially support life. Of the ones that potentially support life, some actually develop life. Of the ones that develop life, some develop intelligent life. Of those that develop intelligent life, some release detectable signs of their existence into space. And then of those, we need to factor in a length of time for which those detectable signals are cast into space. So what we're doing, anytime you have to go from here to here to here to here, right? In other words, you kind of have a parlay of things going on, don't you? This has to happen, this has to happen, this has to happen, etc. Just like the rolling of the die and flipping a coin. Both things have to happen. Only here, many things have to happen. So what do? You multiply them together. All right. Well, we have original estimates. And again, I'm not going to go through the equation again. We've already gone through that, but we're going to substitute in 1 for R. We're going to substitute in a range here. In fact, we're going to go with the minimum number, okay, here. We're going to go with the minimum number in each case, okay? And if we multiply all these numbers together, we get approximately 20, right? Again, this is where there is tremendous controversy, right? The concept is easy. Multiplying numbers. The assumptions, again, these are extremely debatable. This is one person's or maybe one group's assumption. We get approximately 20. However, there was a mathematician his name was Shermer, and this was back in the 60s again. He estimated virtually 0. And again, I don't have his numbers offhand, but of course, depending upon your numbers, right? If this fraction is very small, right, and we have very small numbers, we're going to get very closer to 0. However, there are some estimates that have as much as 15 million, right? A wide range. Anyway, so what did I want to do with this? I just wanted to have some fun with this equation, right? But the main purpose is to show you this main concept that we often use in probability, and we can use that in everyday life, right? Again, if you're going on vacation, whatever, if you're trying to figure out the number of ways that you can take 3 courses, if let's just say you're a part-time student, you're going to take 3 courses, and you want to know how many ways that can be done. And you can take one of 2 teachers here, one of 3 teachers here, one of 4 teachers here. What do? You multiply 2 times 3 times 4, you get 24. 24 different ways you can do that. You can do that with probabilities also. In fact, many of you are football fans. We're coming upon the playoffs, right? And very often that is how we, bookmakers, or perhaps you've done it yourself, you can multiply the probabilities, the expected probabilities that your team needs to win each of the games. You multiply them together. That's the probability they win the Super Bowl, right? Lots of contexts we can use this. So I will end it at that. Thank you for watching. Please hit subscribe if you have not, and see you next time on A Likely Story.